Hello students, my name is Shashank Shekhar. So let us continue with the exercise of NCERT. The first question says that you have to write the electronic configuration of the following ions. So how will write it? So first of all, the question is for hydrogen. So you know that hydrogen has atomic number of 1, so it will have 1 electron. And since 1s orbital is having the least energy, therefore that electron will go to that orbital. So we will have 1s1. Now it is written not hydrogen, means it is not the neutral species, but it is written in the form of H minus. So H has 1 electron and H minus will have 1 plus 1 electron. 1 electron that it already had and 1 electron that is being added due to the presence of this negative charge. So they are total of 2 electrons. So what will be the electronic configuration for this? It will be 1s2. Okay, it will be 1s2. Next, we have sodium plus, that is Na plus. What is the atomic number of sodium? If you remember, it is 11. Okay, it is 11. So sodium has 11 electrons and we have removed 1 electron due to introduction of positive charge. So 11 minus 1, that would give us 10 electron, and hence the answer will be, so first we have 1s2, 2s2, 2p6. Now if you'll ask me how I am writing this order, so we are seeing the n plus L value. So if n plus L value is smaller, then it will have less energy and it will be filled first, and if n plus L value is larger, then it will be filled later on. Now if two have the same n plus L value, then the one with the smaller value of n will be given the least energy. Okay, clear? So here you can see very clearly that 1s has the value of n plus Ls. So n value 1 and s value 0, therefore n plus L is equals to n plus L is equals to 1. For this it will be 2, for this it will be 3. Clear? Now s orbital can have, s subshell can have 2 electrons at maximum, so it will acquire 2 electrons. Similarly, this is also a s subshell, so it will also acquire 2 electrons at maximum. P subshell can acquire 6 electrons, so it will have 6 electrons. So there are total of 10, 6 plus 2 plus 2, that is 10. So this will be the electronic configuration 1s2, 2s2, 2p6. Next is what? Next is O2 minus. So first we will see oxygen. So oxygen has total of 8 electrons. O2 minus means we have O2 minus means 2 electrons are added. Therefore 8 plus 2. Therefore 10 electrons. So we will write it again 1s2, 2s2, 2p6. So this will be the electronic configuration. Next is F minus. So F minus has 9 electrons. F has 9 electrons. F minus will have 10 electrons. So therefore we can write it as 1s2, 2s2, 2p6. Got it? So this 3 will be the electronic configuration of each of these. This one, and this one, and at last of fluorine. Now next, what are the atomic number of elements? So the outermost electrons are represented as this. So this is the outermost electronic configuration. Sorry for this mistake. It will be 3s1, 2p3, 3p5. Now since it is 3s1, what does it mean? It means that the inner orbitals are already fulfilled. So we can say that 1s2, 2s2, 1s subshell, 2s orbital subshell, and 2p subshell are filled. So they will have 2, 2, and this one will have maximum of 6. At last, it is written as 3s1. So therefore, 3s1. So there are how many electrons in total? 6 to 10 11 electrons for A. Now, what are the atomic numbers? So the atomic number would be 11. After that, we have a question that says that we have 2p3. So 2p3 means 1s2 and 2s2 are filled, and we are left with 2p3. That will give a total electron of 7. So the atomic number will also be 7. Got it? Next is 3p5. How will write 3p5? So if I ask you which has a greater value, so this is how much? 1s2, 2s2, p6, 3s2. Then after 3s2, which will come? See, it is a n plus l value of 1. It is also 1. It is 3. It has also 3. Then if we talk about 3p, then it has a value of 3 plus 2. That would give us 3 plus 1. That would give us 4. Clear? This will give us 4. Now let us compare it with 4s. So 4s will also have a value of 4. But since n value is larger, so therefore we will give lower energy to 3p. So 3p5. Now if we count the total number of electrons, so 2 plus 2, 4. Sorry, 2 plus 2, 4. Plus 6, 10, 12 and 17. So 17 electrons for this. So therefore the atomic number will be 17. So we have 11, 7 and 17. Next question. Which atoms are indicated by the following configuration? So helium has a total of 2 electrons. So hydrogen, helium, then we have 1 extra electron, that is for lithium. What is the electronic configuration of neon? If you remember, 1s2, 2s2, 2p6. So it will have total of 10 electrons there and plus 5, that is 13. So 1s2, 2s2, 5 and 2p6, then 3s2 and 3p3. So after neon, then we have sodium, magnesium, aluminum. Okay, sodium, magnesium, aluminum, silicon and phosphorus. It is phosphorus. That is P. So how I have identified it? So very simple. So first we will write neon 3s2, 3p3. This is written. So for neon it is 1s2, 2s2, 2p6, then 3s2 and 3p3. So total number of electrons are 6 for 10 plus 5, 15. 15 electrons are there. So 15 is the atomic number of which atom? So if you count it, which element? So sodium is 11. So sodium, potassium, calcium, magnesium, aluminum, silicon, phosphorus. Hydrogen, helium, lithium, beryllium, sodium, magnesium, aluminum, silicon, phosphorus. Okay, so it is phosphorus. Clear? Next we have argon and then 4s2 3d1. So 4s2 3d1 means initially we will have 20 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, right? Then 4s2. Then it will have 3d1. So this will be the inner configuration. So if you want to validate this configuration order, then you can calculate the n plus l values for each of them. For it will be 1. For 2s it will be 2. For 2p it will be 3. For 3s it will be 3. 3p will have a value of 4. Okay. 4s will have a value of 4. 3d will have a value of 5. So 1, 2, So both have 3. So the one with the smaller value of n will be placed first, then the 3s, then 3 is over, then 4, again 4 4. So we will take 3 1, then again 4s, then 3d. Clear? So which atom can it be? So let us count the total number of electron. 6 for 10, 10 and 10 20 and 21. So if you remember, which has atomic number of 21, so we can just count it: sodium, potassium, calcium, scandium, titanium, scandium. So sodium, potassium, calcium. Okay, so this is calcium, right? It is calcium which has this much number of electrons. So let us see the solution. So first, H minus will have 1s2. I have told you N plus Na plus will have one extra electron released, so that would give it 1s2 and 2s2 and 2p6. Then O2 minus will again have the same configuration, and again fluorine minus will have the same configuration. Next is, you have to write the complete electronic configuration first. We have written this also. We have seen it was 11. Then 2p3 it was 2, 2 and 3, that is 7. And for 3p5 we have 1s2, 2s2, 2p6, 3s2, 3p5, that is 17. Helium, next was we have to write the name of that atom. It is lithium for initial one. Second one we had phosphorus. Third one we have scandium. Clear? Now next, let us see the next question. What does the next question says to us? Next question says that what is the value of n that allows g orbital to exist? Okay, so if you write the order, then it is S, P, D, F, G. So this is the order. So for n, for different orbit subcell, the values of n are 1. Okay, so for 1s, we have, for s orbital to exist, we should have n is equals to 1. For p orbital, we should have, so 1s, then we have 1s, then we have 2s and 2p. So for p, we should have 2 or 2. For D, we should have 3s, 3p, 3d. For, say, for F, we should have 4s, 4p, 4d, 4f. That is, value of n should be 4. Here should be 3. Here it should be 2. Here should be 1. For G, it should have a value of 5. Okay, so 5 would be your correct answer. So it is written very clearly that for G, L is equals to 4. Now since L is equals to 4, we know that L values ranges from 0 to n minus 1. Okay, so that would give us a value of n is equals to 5. Clear? Next, what is the question? Electron is in one of the 3d orbital. Give the possible value of n, L and ml. It is written that the value electron is in one of the 3d orbital. So what is the value of n? It is clearly 3. What the value of L here? So D means 0, 1, 2. That would give us 2. What is the value of ml? What are the possible values of ml you can give? So if you remember, this is the way of writing ml. So this is 0, this is minus 1, minus 2, plus 1, plus 2. Okay, so ml can have a value of minus 2 or minus 1 or 0, plus 1 or plus 2. So 5 values are possible for ml. Okay, so same thing written here. Possible value of n, that would be 3. Possible value of L, that is 2. And possible value of ml, that is minus 2, minus 1, 0, 1 and 2. An atom of an element contains 29 electrons and 35 neutrons. So what does it mean? So it means that the atomic number is 29 and the number of neutron is 35. What is the number of proton then? So since number of electrons and protons should be equal for a neutral molecule, so number of proton will be 29. That is equals to the number of electron. What is the electronic configuration of that element? How you will write it? So if you remember, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So we have 20 electrons. Now we have to place more 9 electrons. How will place it? So for that we have 4d9. Okay, we have 3d9. Now which element has the electronic configuration of 3d9? So if you remember, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper. So this is copper. You can also write it in this form, that is argon 4s2 3d9. Okay, so it is again written right, copper. Now one more confusion is here. So why it is written 4s1 and 3d10? If I ask you, why is it written 4s1 3d10 and not 4s2 3d9? So the reason behind it, so if you write it in this way, then you can see that both the s orbital of fourth principal quantum number and d orbital of 3 principal quantum number have half filled in a case of s and full filled in case of d. But in this configuration only s is fulfilled and d is not, neither half filled nor fulfilled. So this is more stable configuration. Next is give the number of electron in the species of H2 plus, H2 and O2 plus. Now one H has 2 electrons. So sorry, 1 electron. So 2H will have 2 electrons. Now since plus is there, so it will have 1 electron. Next we have H2, so it will have 2 electrons. 1 O2 has how many electrons? 6 2 is 12. Sorry, 8 electrons. Now since 2 are there, so 8 into 2. Now for positive charge minus 1, that will give us 16 minus 1, 15 electrons. So it is mentioned here also. So H2 has 2 electrons. H2 plus will remove 1 electron and will have 1 electron. H2 will have 2 electrons. O2 will have 16 electrons. By adding plus on this, we will remove 1 electron. So we'll left with the 15 electrons. Next is an atomic orbital has n is equals to 3. What are the possible values of L and Ml? Okay, so what are the possible values? So if you look here, if you remember, then for n is equals to 3, there can be values ranging from 0 to, how many values can be possible? 0 to n minus 1. So 0, and what is the value of n minus 1? That is 3 minus 1, 2. So we can have what numbers in between 0, 1 and 2. So these are the possible values of L. Now if I talk about Ml, list the quantum number Ml of electrons of 3d orbital. It is mentioned here that it should be 3d orbital. So 3d orbital means value of n will be 3, value of L will be 2, and value of Ml can be minus 1, minus 2, minus 1, 0, plus 1 and plus 2. Now next, this question. What are the possible values of Ml? It can be minus 2, minus 1, 0, plus 1, plus 2. Which of the following orbital are possible? So for 1, can 1 have the p electrons? Can 1 have the p orbital? So let us see. 1 can have values from 0 to n minus 1. So n minus 1 would also give 0. Therefore, it will have only the value of L as 0 possible. If I talk about second principal quantum numbers, and it will have 1, 0, 1 and 2. So S, P and D. So S is possible, so 2S is right. Similarly for 2, 2P is possible, so 2P is right. Now for third, it will have 0, 1, 2. So 0 will have S, 1 will have S and P. Okay, sorry, 1 will have P, and 2 will have D. So we can have maximum to D. So F is not possible, so it is also wrong. So this one and this one both are wrong. The possible values of L can range from n minus 1, 0 to n minus 1. Thus, for n is equals to 3, the possible value of IL are 0, 1, 2. The total number of ml is equals to 2, 2 plus 1. Its value ranges from minus L to plus L. Therefore, it will have m0 will have 0 value, m1 will have minus 1, 0 plus 1, m2 will have minus 2, minus 1, 0, 1 and 2. Next, for 3D orbital, value of n will be 3, value of L will be 2. For L is equals to 2, possible values are minus 2, minus 1, 0, plus 1, plus 2. Now it is possible for 2s and 2p to exist, but 1p and 3f does not exist, as I have said you earlier. Okay. So similarly for the 3f orbital, n is equals to 3 and L is equals to 3, which is not possible. Using SPD notation, describe the orbital with the following quantum number. Okay. We have to use SPD notation to describe the orbital with the following quantum number. Got it? So this is n is equals to 1. So since 0 is corresponding to s, so 1s. N is equals to 3. 1 is corresponding to p, so it is 3p. N is equals to 4. 2 corresponds to d, so it is 4d. And n is equals to 4. L is equals to 3 does it for f, so 4f. 1s, 3p, 4d and 4f. 1s, 3p, 4d and 4f. Explain giving reason which of the following set of quantum numbers are not possible. You have to see that which quantum numbers are not possible. Now if n value is 0, then it is wrong because 0 to n minus 1. Okay, so it is not possible to have value of 0. 1 can have a value of 1, okay, 0, 1s and ml 0, etc. Correct, it is also correct. Again, n can value of a value of f 1, but it cannot have p orbital, so it is wrong. 2 can have 2s and 2p, so L is equals to 1 is for 2p, so correct. Now ml will have 0 values, okay, and ms will be minus 1 by 2, so it is correct. N is equals to 3, N is equals to 3. It is not possible because 3 does not have f orbital. ml is equals to minus 3 is possible, so the rest of the statement is also false. N is equals to 3, therefore L is equals to 1. Yeah, it is possible to have 3p and at 0 orbital and ms equal to half. Clear? Not possible. The value of n cannot be 0. Possible. Not possible. The value of L cannot be equal to that of n. Possible. Not possible. For value of n is equals to 3, L cannot be 3. Possible. साढ़े 4 साढ़े 6 में उसमें ले रहा था उस वाले में, पीछे वाले में। अच्छा वो हटेगा अभी। यहाँ जैसे इस वाले का तो स्लॉट नहीं बना हुआ था ना, पीछे वाले का बन गई है, दिखा रहा ना। आपने ले लिया था क्या? अरे यार ये कब बन गया ये? अदिति में आई तो थी, चली गई, फिर उनको छींक आने लगी तो। अच्छा मैं इसे खत्म कर लेता हूँ फिर। ये 2-3 क्वेश्चन बचे हुए। Now in this we will see how many electrons in atom may have the value of following quantum number. So for n is equals to 4, so for 4 subshell you can have 4n square, that is 2n square is the formula for this. Now for number of electrons, okay, now n has a value of 4, so 2 into 4 square, that is 32 electrons are possible for n is equals to 4. Now in the same orbital, in one orbital 2 electrons can accommodate, so 16 electrons, 16 means 16 pairs are there and one pair can have only 1 minus half, so therefore 16 electrons is the correct answer. Now it is given n is equals to 3, L is equals to 0. L is equals to 0 means L has a value of 0, that is S, and 3, that is 3. So 3s. So 3s has only one orbital, so therefore it will have 2 electrons. So 2 here and 16 here. So it is written ms 16 and this is 2. Okay. Show that the circumference of the Bohr orbit for the hydrogen atom is an integral multiple of de Broglie wavelength associated with the electron revolving around it. So what it is written? It is written that the circumference, that is 2 pi r, is equals to the integral multiple of de Broglie wavelength. So de Broglie wavelength is h by mv with the electron revolve. We have to prove this thing. Okay. Now we know from postulate of Bohr that mvr is equals to nh by 2 pi. We know this thing. Clear? And from this we know that lambda is equal. So to prove this thing, 2 pi r is equals to n multiple of de Broglie wavelength is lambda. So we have to prove this. And from de Broglie wavelength we know that lambda is equals to h by mv. Clear? So what can we write here? mvr is equals to how much? Now if you put the value of mv here, that will be lambda is equals to h by mv is equals to nh by 2 pi. Okay, so let us first find out the value of mv from this equation. So that would give us mv is equals to h by lambda. Okay, so h by lambda is into r is equals to nh by 2 pi. This h and h will be cancelled out and we will get it as r. Okay, this h and this h not. This h and this h will be cancelled and we will get it as 2 pi r and lambda. So it is proved. So this is the statement that is being made here. So we will write here. So you can see very clearly MVR is equals to NH by 2 pi. This is according to Bohr's postulate, and lambda is equals to H by MV. This is from de Broglie equation. We will take out the value of MV, put this here, and finally we will get here n lambda. Okay. Now since 2 pi r is the circumference, so therefore we will get it as 2 pi r is equals to n lambda. Clear? Next is, which transition in the hydrogen spectrum would have the same wavelength as the Balmer n is equals to 4 to n is equals to 2 of helium plus spectrum? What it is written is that what transition in the hydrogen spectrum would have the same wavelength as the Balmer transition from n is equals to 4 to n is equals to 2. So you have to see. So for what you will do this, you have to find the wavelength that is associated with this thing. Okay, associated with this. Now for a hydrogen, the final orbit will be fixed, that is will be 1 always. Okay, so because the ground state is 1 for hydrogen. So first we will find the value of lambda here. So for that we have 10967 as the wave number, that is nu bar 1 by n1 square minus 1 by n2 square. Here we will find the lambda. Then we put this lambda value in the hydrogen with n1 is n final is equals to 1 and n initial we will have to find it. The same thing is been done here. So first we have found out this value of lambda, that is 4 by 3r. Okay, and we have put this value here for n is equals to 1 and n is equals to 2. It is clear. Okay, so this is for hydrogen, He plus. So with this I end my lecture. Thank you.